Hello students, in this lecture we are going to discuss the group data statistics using the class interval methods. We use the class interval methods when we divide our data in classes or intervals, and those classes or intervals are we call the groups. Usually we use these class interval methods of dividing the data in classes and groups or intervals when in the data itself we do not have particular categorizations to call those categorizations as the groups. Like for example, if we have a data set comprising of males and females, then we can say this set of males is one group and this set of females is second group, and then naturally we have a data which has groups in it. Or for example, we have a data set comprising of some students having GPA greater than 3.5, some students having GPA in between 3 and 3.5, and the rest of the students having GPA less than 3, then we can have three groups in the data by itself. But we use the class interval method again when we do not have such groups present in the data set. And it's a simple technique and a very much used technique in the statistical data analysis, and we'll try to understand it using a simple example. So suppose this is the data set that we have got. It is the same data set that we use for the ungrouped data statistics as well. And again, by virtue of this example, we'll try to understand this thing as well, that the same data can be analyzed and summarized both as group data statistics as well as ungrouped data statistics. There could be difference in the answers of the analysis that we will take later on, but both are acceptable. So this is the data set that we have. It is already in the ascending order, as we can see, but it's not necessary for the data to be in the ascending order when we are doing the class interval method of group data statistics. So this is the data set that we have, and we want to create classes in this data. And now we'll see that how could this be done. So the first and the most important question, that how many classes can we make? How many groups can we make in this data set? To answer this question, there's a systematic way to solve for this problem, and we have a proper formula for it. If small n, let's say, indicates the number of groups that we can have, the caps n indicates the data set size, then log of caps n to log of 2, or the log of data set size to log of 2, is the result which gives the total number of groups that we can have in our data set. Now for our example, we had 17 values in the data set. So this means that log 17 upon log 2, that is 4.08, is the answer to the question that how many groups we can have in the data set. Now the big problem over here is this, that the number of groups is some entity that should always be an integer number. I mean, it makes sense to say that we have four groups in the data. It makes sense to have to say that we have five groups in the data. But saying 4.08 number of groups in the data set does not make much sense. It should always be an integer number. So from here we have to decide that should 4.08 be taken as 4 or 4.08 be taken as 5. Now, by the rules of the rounding off of the data that we study in the algebra or mathematics, we know this thing that 4.08 should be truncated to 4. And if you do so, then probably it might be okay according to the rules of the rounding off of the data, but over here this will not satisfy the requirement. Because the thing is that if we truncate it to 4, that means then it would mean that we are taking four groups in the data set, but we have a decimal value of 0.08, and then we would be losing that information, and we do not want to lose any information, because losing the information would result in erroneous analysis of the data. So the rule that we use over here is this, that whatever value we get by taking the ratio of log n or log data set size to log 2, we have to round it up to the next higher integer number. Like for example, we got 4.08 over here, then we will round it up to 5. and it means that in all we can have 5 groups in the data set. Now let's start making the groups. We have come to know that we can have 5 groups in the data set to give a good analysis. So let's start making the groups. So suppose I make a class interval table. We normally summarize this data set in the class interval table, and the first column we call as the class. And in this column, the first class I have already put, and this is the first value of my data set, or the lowest value of my data set. And this is 118, right? This 118 has come from the data set itself. So 118 is here, and I'm going to start making my classes from this lowest value, which is 118. Now the thing is this, that when we put the classes in this first column, we basically put them in this way, that we just put the lower limit and the upper limit of the class. So we have got the lower limit of our first class. Now what should be the upper limit of the first class, or what should be the lower limit of the second class? So these two very important questions. In order to answer this question, we need to know the class width and the class height. Class height is the vertical distance between the two lower limits, corresponding lower limits, or two corresponding upper limits. And class width is the horizontal distance within the class. That is, it's a distance, or you can say the variation between the lower limits and the upper limits of the same class. So we have again a systematic approach to answer this question. Class height indicated with a small h is the ratio of the range in the data set divided by the total number of groups that we can have. So the range is the difference between the max and min value of the data set, and we know, we can see from here, that the maximum value in our data set is 154 and the minimum value is 118. So the difference of the two, 154 and 118, is 36. So this means that 36 is the range in my data set, divided by 5 gives 7.2 as the answer. 7.2 means that 7.2 should be the vertical height. But again, we just not put it as 7.2. The rule says that we are going to round it up to the next higher integer number. And 7.2 is rounded up to 8. And the truncation of this 7.2 to the lower number, which is 7, would become the class width. So this is the rule. Truncated value is the horizontal or class width distance, and the rounded up value is the vertical height. So let's start working with it. We have got 118 over here. We round it up to the h value was rounded up to 8 integer, from 7.2 to 8. So 118 plus 8, that is 126, is going to become the lower limit of class 2. Then 126 plus 8, that is 134, is going to become the lower limit of class 3. Then 134 plus 8, that is 142, is going to become the lower limit of fourth class. Then 142 plus 8, that is 150, is going to become the lower limit of the class fifth. And we are done with the classes, because earlier we had determined that in all we can have 5 classes in our data set from the analysis, from the calculations that we did. And the horizontal distance we just calculated was 7. That means 118 plus 7, that is 125, is the upper limit of class 1. Then 126 plus 7, that is 133, is the upper limit of class 2. Then 141 is the upper limit of class 3. Then 142 plus 7, that is 149, is the upper limit of class 4. And then 150 plus 7, that is 157, is the upper limit of class 5th. So these are our classes that we have determined. The next thing that we need to put over here in the second column is the frequency. By frequency, we mean that how many values we have within these intervals, including these intervals. So if you look into the data set, so from 118 to 125, we have got 1, 2, 3, 4 values. That means the frequency of this class would be 4. Likewise, from 126 to 133, including 126 to 133, we have got 1, 2, 3, 4, 5, 6. So the frequency of this class would be 6. Then 134 to 141. How many values we have got, including this, including these values within this interval? So 134 to 141, We have got 1, 2, 3. So three values, or the frequency is 3 for this class. 142 to 149. How many values have we got over here? 2. 142, 149, just two values. So the frequency of this class is 2. And 150 to 147, 157. So how many values are here? Again, there are just two values, as we can see, 150 and 154, including these limits and within this interval. So the frequency is 2. In the end row, let's do some totaling, summing up the things to see that whether our results are correct or incorrect. So 4 plus 6 is 10, plus 3 13, and 4 is 17. That means the total frequencies is 17. And this should be equal to the total data set size. So it's a verification that we are on the right track. And the third column that we are going to add over here is the relative frequency, or which is also called as the probability. Relative frequency is the ratio of the two frequencies, that is the frequency of the class to the total frequency. So you can say that it is the probability value as well. The probability of one class occurring is the relative frequency of that class. So 4 by 17, for example, is the relative frequency for class 1. 6 by 17 is the relative frequency for class 2. 3 by 17 is the relative frequency for class 3. 2 by 17 for class 2. And again 2 by 17 for class 5th. And the sum of all these values should be equals to 1, as the rule of probability says that the sum of all the mutually exclusive events in a random experiment is equals to 1. And this is happening over here as well. Then basically it means that every class is mutually exclusive to the other class. And the fourth column that we are going to add over here is the cumulative frequency. Cumulative frequency means that summing up of the class frequencies. So the first class frequency that we had was 4, the second was 6, so 6 plus 4 makes it 10. The third was 3, and 3 plus 10 makes it 13. We are going to sum the frequencies in this way. The frequency for class 4th was 2, and the sum of the previous frequencies of the previous classes was 13. So 2 plus 13 is 15, and likewise again 2 plus 15 is 17. So this is also a verification that this last frequency should be equals to the total frequency that we have got in the data set. And basically it means the interpretation of the cumulative frequency is this, that I mean from till 125 we have consumed 4 values of our data set. Till 133 we have consumed 10 values of our data set. Till 141 we have consumed 13 values of our data set. Till 149 we have exhausted 15 values of our data set. Until 157 we have exhausted 17 values of our data set. So this is a very important parameter when we are working with the quartiles, percentiles, and deciles. Talking about these quartiles, percentiles, and deciles, the another very important summarization parameter is the class boundaries. Class boundary is basically used to make the data continuous. We can see this thing, or make the classes continuous rather. We can see this thing that there is a difference between the classes. There is a different space between the classes. Like class 1 ends at 125 and class 2 begins at 126. So there's a difference of 1 between the two. So class boundary is used to fill up this space. It is used to jam the classes together. And the rule is very simple. What we do is this, the formula is also provided over here. What we do is this, we first find the jamming factor to jam or bound the classes. And this jamming factor is the lower limit of class 2 minus the upper limit of class 1 divided by 2. And then we add and subtract this jamming factor with the upper limits and lower limits of the classes respectively. So what we are going to do over here is this. We have the lower limit of class 2 is 126. The upper limit of class 1 is 125. The difference between the two is 1, and 1 upon 2 is 0.5. Then it means we are going to subtract 0 0.5 from the lower limit of every class and add 0.5 to the upper limit of every class. So this means this would become 117.5 to 125.5. Likewise, this would become 126 minus 0.5 is 125.5, and this would become 133.5, and this would be 133.5 to 141.5. Sorry, a typo. Then we have 142 minus zero point 0.5 is 141.5, and 149 plus zero point 0.5 is 149.5. Then we have 150 minus zero point 0.5 is 149.5, and then 157 plus zero point 0.5 is 157.5. Now, the fourth important column in the summarization of the class interval table is the class mark. The class mark, or sometimes also called as the X value, capital X value, is basically the representative number of the class. That is the average of the upper and lower limit values. So, for example, we have 118 and 125 for class 1. So, 118, and the average of 118 and 125 is basically 118 plus 125, and the answer is then divided by 2. So this is 121.5. So 121.5 is the class mark of class 1, right? Like 126 and 133. The average of the two is basically 129.5. Similarly, 134 and 141, the average of the two is 137.5. Likewise, 142 and 149, the average of the two would be 145.5. And lastly, 150 and 157, the average of the two is 153.5. And this completes our class interval table. A similar table has already been made and is shown over here. So you can see the table that we just made is same as this one. Important thing again to remember these columns, and besides, in addition to these columns, we should also remember the nomenclature that we are using, and we are going to use it throughout. Capital N is indicating the total number of values in the data set, and small n is the total number of groups or classes in the data set. So I hope this is understandable to you. The formula that we have used over here are all indicated in this slide: class mark, class boundaries, class width, class height, the number of classes that we want, and the way they have been used in the data set have been shown over here. So if you have any confusions in making the class interval table, then you can write it on the comments, and I will respond back to you soon. Thank you very much. Stay safe.